Okay, now I have just told you that getting the line of the best fit or getting the best fit regression line after analyzing the scattered plots uh, by viewing the scattered plots, it is difficult to assign the best fit line. Okay, we can put several ideas over here that how about the best fit line could be this, or it could be this. Also, we can say that how about the best fit line is drawn like this, uh, perhaps like this. So you see, you are having several ideas, so which you are going to select, it is now difficult for you. So you need a proper guidance, a mathematical guidance, a mathematical method to obtain the line of the best fit. A line of the best fit is that line that should give the minimum possible errors. And mathematically, if we just try to get the ideal case, we are going to say that the best fit line is that line that should give us such errors that when we add them, it should give us zero answer. So that is said to be the line of the best fit. Okay, that is said to be the line of the best fit. So how we are going to analyze this thing? So the best possible the best and the very easy going way of obtaining the line of the best fit is called the ordinary least square method. There are several other methods too, but out of all those methods, the ordinary least square method is the best one, and that is so abundantly used throughout the world by the statisticians. Okay, so what exactly the least square method is, what this square concept, from where this square concept comes from. So let me assign a best fit line on my own analysis. Okay, let me draw the best fit line. On that case, then we are able to understand the concept of our least square. This is the best fit line. Okay, 2 points are lying on it and the remaining ones are very close to it. Now let us calculate the error, means the distance between the actual point and the corresponding predicted point. Okay, so let us calculate the error. For that purpose, let me select a different color. Let me minimize the stroke. Okay, now that's the best thing. Now over here you see this point is actual value, it is lying on the best fit line, so it is the predicted value as well. Okay, so here there's no error because the difference between both values is zero because both are same. So the same thing is over here. The error regarding this point is also zero because it is not only actual value, it is also the predicted value because it is lying on the best fit line. This point is the actual value, and the corresponding point, which is the predicted point, representing the same value of x, lying on the best fit, is over here. Okay, so this is the distance between the actual point, actual value of y, and the predicted value or estimated value of y. This is the error. You just calculate the length of this line. Let it be, for example, 1 centimeter. Okay, so you just draw a square of 1 centimeter. Okay, finish it up. It is also 1 centimeter. So the error on the 2D plane is occupying this much area. Okay, because once you are discussing this best fit line on a 2D graph, so the influence of the error is on the plane. Once it is on the plane, so there comes the concept of area, because area is a two-dimensional thing. So the region so affected by this error is this much. Okay, similarly, you just calculate the corresponding square area of this error as well. Calculate the length of this blue line. and then draw the corresponding square. Okay, let's talk about this point. Its distance from the predicted value is very small. Okay, let it be, for example, it is of 0.4 centimeter. Draw the square of the 0.4 centimeter length. It's this much. Okay, so it is like that. So in the same way, you just draw all the possible squares and then you sum up the length of those squares. Should be drawn over here. Okay, these are the possible areas of the corresponding errors of each value of your sample data. Okay, and you just sum up all these squares, which are the squares of the errors. Okay, you sum them up, and then you just try to figure out that what should be the best fit of what should be the best line that should give me smallest squares, small possible squares. Okay, while plotting the while just analyzing the errors, and while just drawing the possible squares of the errors. That line is taken to be the best fit line that should give us the smallest possible squares of the corresponding errors. Okay, so actually the squares should give you the areas of least value. Okay, so that's why they have said that the least square method is the best way of just obtaining the line of the best fit. That line that should give you the small possible squares is said to be the best fit line. Means that such line that should give you the minimum errors is taken to be a very accurate line and taken as the best fit. So our objective is to minimize the error length. Okay, the distance of this length. So the best line is that line that should give us the least possible error values. Okay, so we just say that we should draw that best fit line in such a way that once we sum up all the corresponding error lengths, it should give us 0 answer. Okay, so that's how the concept of least square method is explaining you. So the ordinary least square OLS, we can find the values for B0 and B1. That is, with the help of the OLS method, you are going to find out the best fit line, and once you obtain the best fit line, you are able to obtain the corresponding y-intercept and the slope of that line. And once these two values are the best possible answers because they are coming out from the best fit line, they are going to give you the best estimate of your beta naught and beta 1. Okay, so that's how you do. So what you do, you actually take out the error, then you take the square. You just do with all the possible sample data values. For example, if you're having 4 values in your sample, you are getting all the corresponding answers of the errors. Then you take the squares of all these errors, and then you take the square of all these errors, then you sum them up. The sum should be 0. Okay, so you can understand the small is will be the value of your error, small will be the square, so their addition is definitely going to give you 0 answer, because I told you that you know well that if you're having some negative answer, for example, you take the square, every time you're going to get a positive answer. Okay, then the square of a negative base always give you a positive answer. Okay, so basically you're having the positive values here. Okay, all the possible values, how can they give you a zero answer? So our objective, our actually the sense of saying all this is that they should give you the answer very, very close to zero. Okay, the summation of all these squares, the summation of all these squares should give you an answer very, very close to zero. For example, 0.000 and 9 zeros, and then you're getting some value. It is extremely negligible, so it's almost taken to be zero. So that's how the sense is talking about. Okay.